All right, so we just saw how we could define functions in C++. So in this case, we had two functions and we had the output of the function. So in this case, this function would return double and this function here would return nothing. And on the right, we looked at its inputs. So this function had two inputs and they were doubles, but if we got rid of these doubles here, it would mean it would take in no inputs and it would return a double and all that. And so we declared these functions outside of the main, and then we define these functions outside of the main. And then we saw how to call these functions within the main themselves. And we saw, and all these functions were, fairly closely related to one another. They're all about rectangles and stuff. But in C++, or just object-oriented programming in general, when we've got a collection of classes and variables which are all closely related to one another, we've got the ability to create classes. So a class is just a collection of functions and variables which all work together to produce or all work to produce one similar aim. So let's say instead of having multiple functions and variables, we just had a class called a rectangle. So I'll just declare that now. So what I've done here is I've just declared a class called rectangle, and within this rectangle, I'm going to give it certain functions and variables. So within a class itself, we can then divide the functions and any variables into two different sets. We can define them as public, or we can define them as private. So generally, a public member, or when I say member, it's just something part of the class. So it could be a function, a member function in that case, or a variable, so a member variable. And so just anything part of the class. So generally a public, something which is public will generally be a function, and I'll just describe a bit more later after I've just written a few member functions. So void get width, and let's have a double get area, and let's just have our privates, double length, double width, and then double area. So with public and privates, this is mostly done for like data integrity. So when a member is private, it means that only functions within this class can touch or access these variables. But similarly, these could be functions which could only be executed within this class, this rectangle class, if we declared a function as private. So we could have defined this get area as private, and that would mean that only this function could be called within this class. So it would have to have some other function which called it as in a function. So it would have to have a function within this class to call this function being used. So when a function is, or when a member is public, so we could have a public variable, for instance, but generally this isn't done much. So when we have a public, it just means that these functions or variables can be accessed from outside of the class itself. So if we create an object, so when we I'll get to that later. So for now, let's just define these actual functions. So in this class called rectangle, we've declared some functions and what their outputs will be. So we have void here and their inputs on the right, so double inputs, and then finally we've got this double as the return and no inputs for the get area. So when we were just doing a function, we saw how we defined it, and it's fairly similar for a class, but slightly different. So what we do is, again, let's just define this get length function. So unlike with functions, we actually have to specify what class the function is coming from. So we just do that with typing the class name, and we give it the function and give it the input. So let's say this is L. So what this is, this double colon symbol is what's called as the scope operator. The scope resolution operator. And what this just does is, it's used to specify what class a function comes from. And so, you could have multiple, you might have multiple classes, and you might all have the same function name. So to specify which function you're defining, as in which class's function you're defining, you give it the class name, and you use this scope resolution to resolve who owns this function. So then it's just pretty much the same as what we did before with functions. Then we just give it some name. So in this case, we've got a double input, and what we'll do is make length is equal to our length. So remember, we've declared this length variable in our class already, and we'll do the same with the width. So just change this to width and change this to W, and W here, whoops, W. And finally, we'll just define the get area. So in this case, it returns a double, and give it the class name and get area. Oops. Then we just say return, and this will be the length times the width. So now we've defined all the functions within our class. So if we want to create a rectangle object, so whenever we make an instance of a class, that's what we're creating an object. So for instance, let's say I've got a paper rectangle. So before we were doing something like double area, and we were saying this area is variable of data type double. But when we have a class and we're defining, so we're declaring paper. So in this case, paper is an object of the rectangle class. So just some slight different terminology there. So in this case, we've built an object based upon the rectangle class. And so once we've made this paper, we can then use all the functions that are public, or also any variables which were public if we had any, but we don't have any public variables. So in this case, we just have access to the public functions we've defined. So once we've we've created our object paper, we can then use the functions within the class. So to do this, we just put a full stop or a period or dot, and then we use the function we want to access. So get length, let's give it a input of 3, and then we get width, and let's give it 7. And then if we wanted to get the area, we could call something area, and then use paper. And remember the get area doesn't take any inputs, it just returns as a double, so it's pretty much just treated as one double variable here. So if we go cout and the area is area, so let's just compile that. So do class cc so 18. Oh, left out semicolon as is tradition. So just put that there and recompile. So what now? 143. Double. Okay. No function double rectangle. Was not defined. Oh, whoops. Okay. So this function will be using the declared variables here. So I was just using the old input variables here of these functions. So that's what happened there. So now that I compile that, if that's it. So yep. So let's just run foo.out. So area is 21. So just a bit of a recap. So we created an object which we called paper, and paper inherits all these functions and variables from the rectangle class. And then once we've created this object, we get access to all the functions within this class. So we want to get the length, get the width, and stuff like that. But when we have a class, there's also what we call as constructors, which are called automatically when a class is created, or sorry, I should say when an object is created. So whenever an object is created from a class's framework, then it gets called. So there's, even if you don't declare it, it's done automatically. So all the constructor is the name of the function, and similarly there's also a destructor, and define that with a a tilde. So whenever this object is created, then this constructor function gets called, and whenever this object dies, so it could be when this program ends, then this destructor function will be called. So I'll just quickly define these functions here. So all we do is rectangle and then rectangle, and let's just say I'm creating a rectangle. And then for our destructor, we'll just so these constructors and destructors are just functions which automatically get called, and if we compile that now, what have we done? So redefinition of rectangle, 40. Haven't spelled anything. No. Rectangle. All right, sorry. So after a minute of squinting, I just realized I had a colon instead of a semicolon, so that's giving me those typos. So compile again, it's all good. So if we just run our function again, so we get this thing spitted out automatically when this object's created here. So before we actually do any of these functions, this function is called automatically, this constructor here. And when we have the program close, the destructor gets called. And so that's, basics of the class, but this doesn't quite match what our previous little aim was, where we had default box asterisk world equals new default box, blah, blah. So remember when we were playing with pointers that there was a bit of different syntax. So we can also create pointers, create objects with pointers. So to do that, we just have to give it the asterisk symbol again, and then paper, and new, and then the class name, and this just to designate the constructor. And when you're dealing with a class with a pointer instead of just without a pointer, you have to, instead of just using the full stop to access the functions, you have to use the dash arrow operator, which can't think of the name at the moment. But so instead of going dot get length, we just say dash greater than get length, and just go 3, and then similarly with the get width 7. So we're just ping what we did before, and then let's just change this over to pointer version where we use the dash arrow instead. So now we have this area is blah, blah, blah. So all we did was change pretty much the syntax of how we call the functions when we converted to a pointer. So remember, this new will set a big chunk of memory for the program when it starts to run, versus without this, the program will just set a little bit of memory, whatever it thinks it will need. So if we compile that and if we run it, see we get similar output, though if you're quite cunning, you'll notice that we haven't got this I finish, I'm going now. So remember when I was saying this destructor function, so this tilde rectangle, it gets called whenever the object dies. So when we were just using a non-pointer for our object, our old paper object, then when this function, when the main finished running, so when it's return 0 got called, then the destructor was called on the class, since it no longer existed within this scope. So anything in braces we call scope. So things only really defined within a scope. It's a bit of asterisk to that statement, but in the most case, saying between braces is referred to as a scope. So whenever an object no longer exists in scope, when we aren't using pointers, it means it's dead. But when we're using pointers what we've done is we've given it a memory address, and with this new, we've allocated this memory chunk. So it's still in the memory, so this can cause a bit of weird issues. So whenever you're playing with pointers, you have to be careful that you delete all this. Sorry, when you're using the new operating specifically, where you allocate a lot of memory, you have to make sure you free up that memory. So what we do is use the delete operator, and then we just give the pointer name to the object. So in this case, it's paper, and what that will do will delete or free up all the memory which the function was using. So if we run it again, we'll now see I've finished, I'm going now, whereas before the object net was always in the memory, so we didn't free it. Now you don't have to worry about deleting any new things in your Geant4 simulation, because this is all handled under the hood, so it's all done automatically by the Geant4 run manager and stuff like that. So you don't have to worry about deleting any of the pointers created with the new operator. And just while we're talking about constructors and destructors, we can also do something called overloading a function. So what overloading is just when we have the same function name, but multiple declarations of it. So in this case, I've declared another constructor, and in this case, it takes 2 doubles as its input. So if I just declare this function, call it double L and double W, and what I'm going to make this do is just make the length and width equal to the input. So instead of calling 2 functions by themselves, I'm just going to create my object and use a different constructor. So in this case, I'm going to go 3 and 7, and I'm going to get rid of these functions here. And let's just delete that old non-pointer syntax. And so if I just compile that, and yeah, so get same input, same output, but so all I did was I overloaded the function, the constructor rectangle, the rectangle constructor function. So I gave the class 2 options to run with, so I could create it with either just this constructor, which just prints out something when it's created, or I could use a constructor which takes inputs. So that was the old one, this is the new one. So with this just populated the variables length and width automatically, and that was how that object was created. So back to what we were originally trying to work out the syntax behind. So with this G4 box asterisk world equals new G4 box, blah, 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 blah. So this G4 box, that's a class. So pretty much, when you go to, whenever you go a class, so in this case, detect construction.cc, all these .hh, and if you create anything with these names, then you're building an object from the class. So in this case, we have the G4 class. Oh, and sorry, while we're talking about classes, so I've defined all these classes here within this one file, and the same file which the main is in. But when we're doing with a real world program where it's much larger, what we do is just split the classes into separate files, so the .hh files. So the .hh files is what contains all the declarations of the program. So if I just open detect construction, So here we've just got our class declarations here. So we've got our public member functions. So it's just a constructor and destructor here, and this physical volume construct function here, and we have no private functions or variables. And if you're wondering what all this if and def and stuff, it's just safety, just in case you have accidentally have multiple classes with the same name. It just stops them from being declared multiple times. So with our program, we have all this declaration stuff of the class within the .hh files, then where we define the functions of the classes, we then put these in the .cc files or the source directory. So we went up there to our source, so all those, the .cc files is where we actually define our member functions of the class. So just in case you're thinking, why I've got my class in the same file that my main is in, just because it's such a small program, it doesn't make sense to split it all up into multiple files like our Geant4 simulation is. So back to our G4 box world. So we now understand, hopefully, or at least we can appreciate what this G4 box class is. So this G4 box, it's a collection of functions and different variables it keeps track of. So, and when we define it like this, so world is an object of the G4 box class, and in this case we create it with the new operator and call it a pointer. So in this case, this new will allocate a chunk of memory, and this world will be a pointer to the object and point to this chunk of memory. And this G4 box, all this is just a constructor of the G4 box class. So in this case, it'd be similar to our rectangle constructor that we had 2 double inputs, but it could also have another constructor which just takes no input. So if you actually just Google G4 box class and look through it, you could see all its functions and variables that it has. So in this case, this G4 box constructor takes an input name, and then it takes these 3 variables here. So if we wanted something similar, we could have something like string, string, string. But in this case, it takes like characters or string, and then 3 doubles or G4 doubles. So so the other thing we wanted a bit of context about was this G4 double. So as we saw just now, standard C++ has its variables of double, and the only difference between these doubles and the G4 doubles is pretty much that the G4 doubles allows you to have units as well as a magnitude. So every Geant4 double or int can have units. So we could have this foo, and that could be equal to an energy, or could be equal to a size, or even a magnetic field strength, or anything like that, or even time. So this G4 double, or all the G4 units, well, most of them have units associated with them, and then Geant4 has its own internal unit tracker, so we can mix, let's say so we could have something like it equals 100 centimeters plus 100 millimeters, and it would be fine. It would just keep track of that. Then if we had some other variable, foo2, and that is equal to 1 kilometer, then if we plus those 2 variables together, so let's have foo3, and that is just foo plus foo2, then Geant4 would be happy with all these mixed units, since it just keeps track of all these units with its internal unit system. So that's all fine. But whenever you're defining Geant4 double or Geant4 int variable, if you want to have units, you just have to put an asterisk at the end, and they'll let Geant4 know what units they are. And similarly, if you've got a Geant4 unit, and similar to G4 double, there's also a G4 cout, which is just Geant4's version of cout to print stuff to the screen. So if you had some variable foo and you wanted to specify what units to print out, all you have to do is divide it by the units you want displayed as. So this is particularly important if you're saving something to a file and you don't specify the units. Geant4 will just choose what units it will output it as. So you should be careful to specify what units that you're outputting, or you should always be careful to specify the units which you're saving a variable as, or otherwise, you might get mixed units, or you might just forget about it and just assume it's some other unit. So just be careful of that. But so hopefully, throughout these last 3 videos saying, you get a bit of an appreciation, possibly not a great understanding, but just have a little bit of context of what we're doing here. So we're creating this pointer to an object of the G4 class, and this is the inputs that we're putting into this class, and from that the class can calculate various things. So hopefully that maybe helps a little bit.